next what we want to do is see what happens when IUV is not 0. Okay. When IUV is not 0, that is I am dealing with the given axis y and z, what happens? If IYZ is not equal to 0, then whatever we did till here holds, this equation still holds, and still I will get y naught as this, z naught as this, okay, and then whatever we did till there holds. So, when IYZ is not 0, I have u in general given by minus y minus y naught d square delta y d delta y by dx plus z minus z naught d delta z by dx Ex plus delta y function of x Ey plus delta z function of x Ez. The dispersion field similar to u and v, I replace u and v with y and z here, remains the same. Then my sigma xx would be minus E times y minus y naught d square delta y by dx square plus z minus z naught times d square delta z by dx square this will be my stress, okay, and then the condition that integral sigma xx dAx Ax has to be 0 would imply that y naught is given by integral E times y dAx. Here I have not assumed the beam is homogeneous, E dAx, and my z naught would be integral E times z dAx by integral E times dAx. Okay. These two you will get from this equation, and then you have the moment equation mz to be given by minus integral y minus y naught sigma xx dAx from our definition in the very first class when we began the beam bending problem. This will be the definition of mz, and you add a definition of my as integral z minus z naught sigma xx dAx, right, Ax. Okay. Now, this will tell us that mz is given by E times I zz d square delta y by dx square plus E times I yz d square delta z by dx square, and my would be given by E times Iyz d square delta y by dx square plus E times I d square delta z by dx square. This assumes beam is homogeneous, that is, it is made of the same material, there is no difference in tension and compression, or there is no difference of materials in tension and compression. Okay. Now, what I have to do is I have to solve these two equations, to get delta y by dx square d square delta z by dx square in terms of my and mz. Okay. So, there will be a negative sign in here. Okay. So, now to solve this equation I cast it in this following form: mz my is equal to E times Izz Iyz minus Iyz, okay, Iyy into d square delta y by dx square d square delta z by dx square. Okay. Now, I invert this 2 by 2 matrix. From here I get d square delta y by dx square d square delta z by dx square into E is 1 by I y z squared minus I z z I y y, okay, into minus I y y minus I y z I y z to I z z into m z m y. Okay. Now, from here I get that d square delta y by dx square into E is I y y into m z plus I y z into m y divided by I z z into I y y minus I y z squared and E times d square delta z by dx square would be minus I y z into m z plus I z z into m y divided by I y y I z z minus I y z squared. Okay. So, we have found these two. Now, going back to the expression for the stress, I will get it as sigma xx would be, going back to the expression for the stress, it will be minus y naught into I y y to m z plus I y z into m y divided by I y y I z z minus I y z squared plus z minus z naught into I y z m z plus I z z m y divided by I y y I z z minus I y z squared. Here the negative sign comes because it is minus y minus y naught into E times d square delta y by dx square. So, that negative sign comes here. Here it is minus E times z minus z naught into d square delta y by delta z square, and hence this negative sign does not propagate into here. Okay. Okay. So, that is the expression for stress. Now, let us look at special cases. Let us look at the case where I y z is 0. Special case where I y z is 0, then your expression for sigma xx becomes minus y minus y naught m z by I z z plus z minus z naught into m y by I y y. Okay. This is the same expression that we got in here. It is same expression that we got in here for sigma xx, except that u and v roles are changed to y and z now, except that u and v roles are changed to y and v now. Okay. U is y, v is z. Okay. So, this m z by I z z as a negative sign, you can see that m z by I z z as a negative sign in here. Okay. So, this is same as what we got there. So, it is consistent now. Okay. The second special case that we are going to consider is when there is movement only along one direction. Case 2, I y z is not equal to 0, but m y is 0. I applied force along only one direction, but I did not apply it about the principal direction. Okay. Now, sigma xx would be minus y naught, my is 0. So, I have Iyy divided by Iyy Izz minus Iyz squared into mz plus z minus z naught into Iyz into mz divided by Iyy Izz minus Iyz squared. Okay. Okay. So, now this is where you have only one moment mz moment, but the stress varies both along y and z direction. Okay.